Hi, my name is Abby. I go to Schreiber High School, and I'm a rising senior. My main project is called Object Detection. For my second milestone, I trained a custom detection model to differentiate between benign moles and melanoma. To start, I opened an app called Label IMG from GitHub in the Raspberry Pi terminal. This allowed me to put boxes around and annotate all of the images in my pre-collected dataset. The annotations got saved as XML files. Then I ran code to randomly divide all of the melanoma and mole images and annotations between training, validation, and testing groups in a 70-20-10 ratio. I repeated the process for the rest of the images. Next, in Google Colab, I installed the proper TensorFlow model maker modules in order to be able to use TensorFlow Lite. Still using Google Colab, I imported the packages of NumPy, quantization config, and object detector. NumPy lets users work with complex arrays. Quantization config makes continuous and complicated inputs and outputs simple and discrete. And object detector allows the model to make inferences about the images it receives as input. Then I uploaded a sample dataset of Android figurines and my own annotated dataset of moles and melanoma images to Google Colab. After that, I chose a TensorFlow Lite model architecture, and there were 5 options, 0 to 4, each of which was slower and more precise than the last. I chose Efficient Det Lite 1, which was a nice combination of precision and efficiency. Then I defined the variable train data as the JPEG files and XML annotations in my training images folder, and did the same with the rest of my data, which was for validation and testing with the variable val data. After that, I trained the model in 25 epochs and 4 batches. This means that the dataset was cycled through 25 times, and since 68 images in total training divided by 4 batches provides an even 17, each epoch took 17 steps to run through. With each new epoch, the loss rate decreased, but not enough to make an entirely accurate model because perfection does not exist. I then evaluated my custom model with the val data set, which reached a maximum accuracy of 75%. I exported my TF Lite model to my downloads folder on the Raspberry Pi, and then in my terminal, all I had to do was reactivate the TF Lite virtual environment mentioned in the last video and change directories to the examples/TF Lite/examples also mentioned in the last video. I copied the melanoma.tf Lite file from downloads to this proper directory, and then I just specified that I wanted the detect.py code mentioned in the last video to run on the TF Lite model that I had created for melanoma instead of the pre-trained model. I struggled most with proper file formatting because my code kept saying that the JPEG files I was using were not really JPEG files, but once I ran them through a JPEG conversion code, the error got resolved. I was also pretty disappointed by the low accuracy of my model for real-life quantized model evaluation because the average precision rate in real life was only between 36 and 47%. This is a result of quantization, which in making the model faster and simpler also reduces accuracy. I did enjoy the simplicity of printing the object detector's predictions in the terminal, and I also found it satisfying to be able to export my custom trained model to detect.py relatively smoothly. For my next milestone, I'd like to improve the accuracy of my custom model and perhaps train a new custom dataset of cancer cell images. Thanks for watching and have a great day.
Go.
Here's the package installation and the imports. And here is the unzipping of the Android and melanoma and mole files. Here we define train data and val data. And this is how the model is actually training. So as you can see, the loss rates of each epoch are printed, and it goes through 25 epochs, each of which has 17 steps. this is how the model gets evaluated, and there are different precision rates depending on how you view them. This exports the model to the directory over here, and this evaluates the quantized version, so that's why it's in general less accurate. Now the TF Lite file gets downloaded to Raspberry Pi, and that's it.